All right, here we are. We're going to be talking about the 5 refrigerants. So we got CFC, HCFC, HFC, and then coming up we have the other 2. I can't fit all 5 on the same page, but these are the other 2, HFO and HC. So let's get into it.
All right, so all 5 of these, I know you're only looking at 3, but they're in order. So CFC is in order of how harmful it is. So CFC is at the top. Then you got HCFC and HFC, and then below that you're going to have HFO and HC. They'll be in 4th and 5th place. Everything is in order based on how harmful it is. CFC is at the top. So CFC, which is chlorofluorocarbon. Only the CFC and the HCFCs have chlorine. Understand that, because there may be a question where they put HCFC, then they'll put HFC, HFO, and HC, and they'll ask you which one has chlorine, and you gotta know that only CFC and HCFC have chlorine, right? So basically, if you see 2 C's, you know that there's chlorine and carbon in it, and you know that the other 3 don't have it, right? But when it comes to chlorine, only CFC and HCFC have it, and then when it comes to carbon, all 5 have carbon. All 5. How I remember that is that human beings are carbon-based life forms, so carbon is in all of us. Carbon is in all 5 of the refrigerants. That's just an analogy how I remember it. As for the chlorine, I think of like chemical warfare, chlorine gas. Maybe you go to the suburbs, they put too much chlorine in the pool, it burns your eyes. It's harmful to humans, so it's also harmful to the environment. So chlorine harmful. CFC has the highest level of chlorine, has the highest level of ODP, which is ozone depletion potential, as well as global warming potential. And I'm going to cover that as well. So ODP and GWP, basically ODP, ozone depletion level, is the chlorine has the highest level of it. So basically what happens is that chlorine goes into the atmosphere, and inside the atmosphere is at the high, in the stratosphere level, they have what's called O3. So like what we breathe is O2. So O3, not really breathable. I don't know level. I know that at that level you kind of have to have an oxygen mask because we can't breathe it. But that layer, that stratosphere, protects us down here. It keeps our levels of oxygen and everything like that safe, right? So the O3 is almost like our barrier. So what happens with chlorine is chlorine goes up into the atmosphere, and just one of those atoms could attach to the O3. It'll see the O3, which is basically 3 oxygen molecules. It'll take 1 oxygen molecule and combine. And you'd be like, well, doesn't that leave O2? That is true. But also what it creates is chlorine oxide, chloromonoxide. Chloromonoxide, which is actually a poison. So chlorine monoxide is very harmful to humans. It's very harmful for the environment. And it adds to the depletion of the ozone layer, so ozone depletion potential. So why that's bad is that now more sun rays are penetrating the earth. Why that's bad is because the thinning of the atmosphere allows more sunlight to hit the earth, which can increase the temperature of the earth. I know that's debatable. We're not here to talk about debatable. We're talking about what's in the literature so you can pass the test. It can reheat the earth, causing global warming. But the biggest thing in the questions is that it causes cancer in humans. It causes increased levels of cancer, cataracts for human beings. So what's essentially happening is that the chlorine is attaching to the oxygen molecule. It takes away one of them. It breaks down, which is breaking down that barrier that we have there. It's almost invisible, right? And the sun is then penetrating that barrier. All right, and what's happening is it's penetrating the barrier, it's hitting the earth, it's reheating the earth, and then it's bouncing off the earth and hitting that stratosphere. And although it's weak, it still has enough potential to bounce that sunlight or that energy back towards the earth. So not only is it heating the earth up faster, it's also hitting our skin, which it causes increased levels of the cancer, which once again, remember that for your test, because they'll talk about what are the negative implications of chlorine in the atmosphere, the negative implications of too much refrigerants being in the atmosphere. So most important question here, though, is also which one is the most harmful, and that's CFC. HCFC is also extremely harmful, but it's less harmful than CFC. HFC, hydrofluorocarbons, remember, this is where they stop. The refrigerants no longer have chlorine in them. So you got hydrogen, you got fluorine, you got carbon. It's got the lowest to no ODP, which means some of these, and be aware, these are groups. So HFC, CFC, there's groups of refrigerants that fall under that. So in that group, some of them have no ODP, ozone depletion level, and some of them had just very, very low ODP. But it has a 1,000 times higher GWP than CO2. So that's global warming potential. So that's basically, it's the potential that it will contribute to global warming, right? So CO2 is considered the baseline with the GWP of 1. And it sounds complicated, it's not, all right? So basically, and I have a chart coming up that's gonna break this down easy. I took all the numbers and I put it into words so that it's simple, but I am gonna explain it a little bit here. So CO2 is the baseline. So basically, when we look at acidity and alkaline, when it comes to water, when it comes to liquids, what is neutral on the pH scale? 7. So we consider, for the most part, 7 is the baseline for liquids when it comes to acidity and alkaline, or drinking water. But obviously we know it's becoming more acidic by the year, but that's not right now. So water is the 7. So when you see carbon dioxide being a 1 when it comes to GWP, understand that there are things that go below 1, like 0. Something could have a 0 rating, which means technically it has a lower global warming potential, which is good, than carbon dioxide, the baseline. So water is a 7, even though it's a baseline, things could be higher or things could be lower. So remember that when it comes to GWP, that it can be lower, it can be a 0, based off of having better global warming potential than carbon dioxide, which is already in the air. So carbon dioxide is the baseline of 1. When it comes to HFCs, the GWP for that can be 1,000 times higher. That is very harmful. Not as harmful as like CFCs, which have a GWP 10,000 times more harmful than carbon dioxide. So CFCs have 10,000 times more harm when it comes to GWP. HCFCs and HFCs both have something that's 1,000 times higher than the GWP of CO2. All right, let's get on to the next slide. All right, so here we are. It's the second slide, coming to the end real quick. So HFO is in 4th place, and then HC is in 5th place for most poisonous, which means HC is the safest out of all 5, and HFO is the second safest, right? So for HFO, I put that, it's hydrogen, fluorine, and carbon, and then I put double bond because HFC is a single bond. So what's in 3rd place, HFC, is a single bond. I don't recall ever seeing that be on a test, but I just added that little tidbit in there just because, why not? So HFC is a single bond, and then HFO is a double bond right here. All right, so as for HFO, we got no ODP, so no ozone depletion potential. Once again, it doesn't have chlorine. But there's a small effect on GWP, global warming potential. HC, hydrocarbon, which is hydrogen and carbon, least amount of danger to the environment out of all 5. No ODP, ozone depletion level, no chlorine, small effect on GWP, and some HCs are actually considered natural refrigerants. All right, so this is the final screenshotable chart. So this is the 3rd chart. I took the numbers. I went through the chart that you get with the EPA manual where it has all the individual numbers for GWP and ODP, and I took them, I put them into words so that you don't have to memorize the numbers, and you won't have to memorize the numbers because, one, they give you the chart at the test. Now, that chart, and it's on the internet. So with that chart, you'll be able to, I'm going to do a whole entire video as well just on how using the chart, because the chart has about 10% plus of the questions around there. So 1 out of 10, I referred to the chart and was able to read the columns. This is basically just columns and rows, kind of like this, just a little more complicated, just a little more rows, but the answers are in there for a lot of questions. And I'm going to have some training questions as well in upcoming videos so that I can show you how the questions work and how to use the chart. All right, so moving on to this actual chart. So as you see, refrigerant, that's the top, that's the header. And then as you go over ODP, that's the header, GWP, and you're going down. So if we go over to refrigerant, we got CFC, you got a little bit of a stop sign. I put a lot of red in there so that you know that this is the most harmful one. When it comes to ODP, ozone depletion potential, it's got the yes. Does it have it? Yes, and it's the highest. GWP, yes, and it's the highest. Remember, it's about 10,000 times higher than carbon dioxide. Going down to HCFC, we got, does it have ODP? Yes, but it's less than CFC. It's in 2nd place. Does it have GWP? It does, yes. Once again, it's in the thousands times higher than carbon dioxide. HFC, yes, but it's low lowest to no ODP. Remember, there was one of the things where some of them have 0 and some are just really, really low. As for the GWP, yes, once again, it's 1,000 times higher than carbon dioxide. So CFC is 10,000 times higher than carbon dioxide. That baseline. HCFC is 1,000 plus. HCFC is 1,000 plus, and then HFO is what we're moving on to next. So does it have ODP? No. No ozone depletion potential for HFO. GWP, yes, but it's a small amount. HC, which is the least danger, no ODP, and yes, but it has the smallest effect.